Hello, everybody, and welcome to the Amateur Science Podcast, a podcast where a non-expert talks about science stuff. I want to thank everybody for listening to episode 1, and I've received a really good feedback on it, so I am very excited to bring this episode 2 to you guys. Now, episode 2 of this show, of the Amateur Science Podcast, is called The Origin of Life on Earth, and this is a really interesting topic that I thoroughly enjoyed researching, and I'm very excited to bring this information to you guys. So let's get into it. 4.5 billion years ago, the planet we now call Earth was nothing more than a hot, molten rock. Day in and day out, it was constantly getting bombarded by space debris, such as asteroids. These asteroids that were besieging our planet eventually brought ice. Now, what ice does is, whenever it gets too hot, it melts. And this ice melted with such tremendous heat, it released gases that surrounded our planet and formed our first primitive atmosphere. As enough of these gases released, they formed clouds that started a torrential downpour that lasted for millions upon millions of years. This rain, it cooled down our planet from being a hot, molten rock into being, just a regular rock. As it cooled our planet down, it filled in our oceans that we have now. These oceans were rich in every sort of compound that is needed for life to thrive. As for any sort of life on this planet, it was non-existent because it hadn't formed yet and was not able to form in the conditions that were on the planet at the time. Our atmosphere consisted mostly of carbon dioxide, and it wouldn't have been able to support life in any stretch. Nobody knows for certain how the first life on Earth originated. Was it brought to our planet by space debris, or was it formed right here in our backyard? There is a theory that life originated in a primordial soup, or a mixture of organic compounds that were found in the deepest depths of our oceans. It's almost as if life just appeared one day. That's likely not the case, but there's been no real conclusive evidence of how life formed. Our early life forms were single-celled prokaryotes. Prokaryotes are cells, usually bacteria, that don't have any membrane-bound organelles or a nucleus. And these organisms, in their early life, they floated along the bottom of our ocean. These organisms, these prokaryotes, were around by themselves for longer than the rest of life combined has been here, all of the multicellular organisms, which is really extraordinary when you think about the grand scheme of things. While these prokaryotic cells just hung out in the bottom of the ocean, over the years they started floating towards the surface of the ocean, and with this they were able to start using water, carbon dioxide, and sunlight to create their energy. This is the first known instance of the process we call photosynthesis. If you know anything about photosynthesis, you know that one of the waste products of this is oxygen. And oxygen is important because, well, it's what we breathe. In fact, these organisms were creating massive amounts of oxygen. The fact that these organisms were creating massive amounts of oxygen might sound amazing, but for life at the time, it was one of the worst things imaginable, because many of the bacteria was anaerobic, or it does not like oxygen. The release of this oxygen caused the world's first extinction event. It's generally referred to as the Great Oxygenation Event, and with this, massive amounts of oxygen being released into the atmosphere killed most of the anaerobic bacteria on the planet. And with the eventual extinction of many of these organisms, there was more room for the oxygen-using bacteria, or the ones that liked oxygen, to fill these niches. Now, prokaryotes are single-celled organisms. However, we're not. So that begs the question, where did multicellular life start? This isn't very clear either. A common theory is that one cell ate another one, and this started a symbiotic relationship. Eventually, this symbiotic relationship kept growing and growing until the first eukaryotic cell appeared. Embedded in rocks around the world, there's evidence of a spiral-shaped organism believed to be the first eukaryotic organism, called Grypania spiralis. Now, there is a lot of conflicting opinions on this organism. Some say it is truly the first eukaryotic cell, while others think it was just a bacterial colony. Keeping on with the theme of symbiosis in cells, these eukaryotic organisms eventually formed relationships, and these relationships progressed over time until the first multicellular life formed. Multiple cells working in unison towards a common goal of living. Over time, these multicellular life forms began forming symbiotic relationships with each other. So these cells that already had symbiotic relationships began having symbiotic relationships with other cells. And this is where you get the first complex multicellular organisms. And every plant, animal, and person you see is a complex multicellular organism. And cells upon cells upon cells working in unison, which is a beautiful thing if you ever actually sit and think about it. Think about how everything around us, every organic compound around us is a bunch of cells working together. And the first complex multicellular animals were likely sponges or other creatures from the phylum Porifera. And from here, many of our ocean's creatures forms, from jellyfish to, the plants, the corals, the regular fish, vertebrates and invertebrates, and just everything in between, all started from these complex multicellular organisms, because there was so much room for them to expand and evolve, and a lot of variations, which is really awesome and just really bigger than you can even imagine. With this explosion of life, eventually over time, with this expansion of life, many of the ecological niches were filling to capacity in this underwater escape. And with the lack of resources underwater, there was only one way to go from there. And this is where life first started to venture onto land. Thank you guys for listening to this episode. If you liked it, please follow, share this podcast with everybody that you know, all your friends, your grandparents, everybody. Everybody's going to love it. And please continue to listen, because I'm going to continue to put out episodes about really cool scientific topics that I'm very interested in. And thank you guys for listening. This has been the Amateur Science Podcast with Jacob Hansen.